Just a moment. Oh wow, that's amazing. Do you want to see it too? Did you buy a ticket for the show? The ticket costs 1 like, and if you want a front row seat, a subscription. Done? Then let's start. So, is there anyone familiar here? If yes, hello to you, fellow microbiologists. If not, don't worry. Microorganisms can live right under our noses, or even on our noses, but we don't see them, and here's why. Let's say we have an eye. If the eye sees 2 points coming closer together, when they're about 0.008 of an inch or 0.2 of a millimeter apart, it starts to see them as 1 point. This is called the resolving power of the eye. If a creature is smaller than the eye's resolution limit, we won't see it at all. But if we equip the eye with a microscope, we will see it. I know you're eager to look through a real microscope. I promise we'll do it soon. But to avoid looking without seeing, I'll give you a short lecture on what we can see there. The identification and systematics of microorganisms can be tricky and confusing. In the macro world, if a horse looks like a donkey, it means they are probably related. If two microscopic creatures look alike, they might be related, or they might not. So we'll go the easy way. We'll divide microorganisms into 4 groups based on relatively clear characteristics. Protozoa are a group of unrelated single-celled organisms that have a nucleus. In other respects, protozoa can differ greatly from each other. Most are heterotrophic and can move using various structures like flagella, cilia, and pseudopodia. Microscopic algae are eukaryotes capable of photosynthesis. They contain chlorophyll or other photosynthetic pigments that give them green, yellow, red, or brown colors. Microscopic fungi are eukaryotes. They feed heterotrophically like protozoa. However, unlike protozoa, fungi are immobile, with very rare exceptions. They can be unicellular, like yeast, or multicellular. If the fungi are multicellular, under a microscope we will see hyphae, long branching threads that make up their vegetative body. Bacteria and archaebacteria are domains of unicellular organisms that lack a cell nucleus. They are usually very simple in shape, like spheres or rods. Bacteria and archaebacteria are much smaller than all other microorganisms, with an average size ranging from 0.5 to 5 micrometers. You might ask, what about viruses? They are small, ranging from 20 to 300 nanometers. They are not visible in a light microscope, only in an electron microscope. They fit the size criteria, but there's one catch: they are not alive. All living beings can reproduce on their own. Viruses cannot. They need to invade a living cell and make it reproduce viral particles. So they are more like living substances. Therefore, we'll add viruses to the mind map, but they will be in a separate group for those who will gonna be real boys someday. Under the microscope, we can see small but multicellular animals. Microbiologists usually do not study such creatures, but it's good to know how to distinguish them from bacteria or protozoa. There are also quite curious scenes in the microworld. Do you know what this is? Algae? Bacteria? No, it's a mosquito antenna. A mosquito is certainly not a microorganism. But all living things eventually stop being alive and start breaking down into small pieces, which we can enjoy looking at under the microscope. I sometimes review the scientific works of students that they send to the Olympiad. Once, I found a picture like this. The student carefully counted the number of bacteria in this photo and even did a statistical analysis. Guys, these are not microorganisms. This is debris. The easiest way to distinguish debris from living beings is by its shapelessness. However, sometimes you can find quite neat and cute debris, just as there are quite shapeless microorganisms. I promised that we would look through the microscope again. Promises must be kept. And this concludes the theory. Now we have to test our new knowledge. If you want to test it yourself, there is a link to my website in the video description. You can complete all the assignments in an interactive program. The program is adapted for Chrome and Firefox on personal computers or laptops. Click the link, close this video, because it will be a big spoiler ahead. Bye bye! And you decide to stay and watch. So take some tea, grab some cookies, and we will do all the assignments together. Our first assignment will be to sort microorganisms. Now we will look closer at them and sort them all out. Here we see thin pseudopodia around the shell. Globigerina is a protozoan. The next one has a simple shape. Vibrio cholerae is a bacterium. Here we see small round spores and a thin thread, a hypha. This is a fungus. The next two creatures are green. They are algae. Again, spores and hyphae. This is a fungus. The simple form belongs to bacteria. Then try to look closely yourself. If it is not clear, ask questions in the comments. The second assignment is to find suitable habitats for the microbes. It's not that easy, but we have a lot of clues. Free one hand from tea and cookies to press pause and read the clue if a choice surprises you. assignment is to find and photograph microorganisms around you, or at least traces of their activity. I'd be much happier if you get off the couch, do this, and send in your photos. We could even create a little exhibition of the tiny critters you can find at home. Oh, we're doing great. What a surprise. That's it, my dear boys and girls. Our story comes to an end. Thank you for your attention, and I hope to see you soon again. Bye bye.